Hi everyone. Today we're going to talk about states of matter again, and we're going to talk a little bit more about how the states of matter react under different temperatures, what their particle arrangement looks like, and we're specifically going to focus on liquids and gases today. Yesterday you did slide 5 of your interactive notebook, and today we're going to work on slide 6, which is going to be liquids and gases. So as you see here, we've got a solid. The particles are very slow. We can decrease the temperature and make them even slower. Liquids, you can notice the temperature is a little higher, a little bit more movement. They slide past each other, and then gases are bouncing off the walls, but the temperature is much higher. The particles are not attracted to each other, and they have the most freedom. All right, so right here we are going to look at some notes. This is page 2 of the notes. We actually got these on Monday. If you are at home, just try to write this down on a blank sheet of paper. All matter is made up of tiny particles in constant, and we want something that goes here, and they are in constant motion. The 3 states of matter we know are solids, liquids, and gases. All right, so gas particles, like we just saw, are usually at higher temperatures, and they move very freely. We said they had the highest degree of freedom. Liquid particles, right here, they slide past each other. So they're not tightly packed together, but they just slide around. And solid particles, our lowest degree of freedom, this guy right here, they vibrate tightly. So even though they are our lowest degree of freedom and they are solid and the object isn't moving, particles never stop moving completely, so they're just vibrating tightly together. So just as temperature changes, thermal energy, so thermal means heat, energy that comes from heat also changes. Therefore, temperature change, I'm going to abbreviate temperature change, so if we increase or decrease the temperature, equals a thermal energy change, which equals a state change. So when we heat things up, we increase thermal energy. We go from a solid to a liquid to a gas. If we change the temperature and lower the temperature and make it cooler, we can go from a gas to a liquid to a solid. Okay, the next thing we're going to look at is the particle arrangement in solid, liquids, gases, and plasmas. So right here it says, how do I compare and contrast models depicting particle arrangement in solids, liquids, and gases, and also plasma? So we know in a solid, particles are going to be very close together. They're going to be touching each other, but remember, they never stop moving completely. They always are vibrating tightly against each other, and the colder it is, the less they move. Liquids are going to be sort of sliding past each other. Notice they're a little bit spread out, still sort of close, but aren't bouncing off the walls yet, but they're more spread out than the solid is. They have more freedom. They can slide past each other. A gas is going to be much farther apart. Okay? If they had a container, they'd be bouncing off the walls. And then plasma, you're going to see, is even farther apart. And remember, those only happen in the stars, in the sun, and we also see it in lightning. So your assignment for today is going to be slide 6. So slide 6, we're going to look at it in just a minute. Remember, you're going to go to Google Classroom. You're going to go to your Google Drive. It'll be on your Google Drive. So you're going to go to your Google Drive, and remember, that's the one that has a little icon that looks like the triangle. All right? And when you go to your Google Drive, you will find your Unit 1 Matter Digital Notebook. Remember, we are not turning this in. This is something that you are going to edit every day, so it's going to be on your Google Drive. If you don't know where to find it, go back to our assignment from yesterday, and it'll be attached. So, from yesterday, this was our assignment. It said solids, liquids, gases, and plasma. And remember, you had your digital notebook right here. I'm not going to reattach that. You're going to need to go back and grab it from here. You're going to be doing slide 6. So, the first thing says read the information on the left. You're going to read this passage about liquids, and you're going to see they've got a diagram right here that you need to focus on. Then we're going to read this passage on gases, and they've got a diagram down here that you need to look at with some really important examples. You're going to take your red circle and you are going to drag it to any of the important words. Now, this is not right or wrong. You choose which words you think are important. The third step says answer the questions by putting the answers and key details on the right. So here, in your key details, you are going to answer this question. How do particles move in a liquid and a gas, and how does the movement affect their ability for them to hold their shape? You need to answer both parts of this question. So I need you to tell me how do particles move in a liquid, but I also need you to tell me how that movement affects their shape. Lastly, I want you to answer this question, why doesn't a gas have a definite shape or volume? The answers are in both of these passages. And then at the very end, write me one sentence that summarizes all of the material. Be sure it's a complete sentence and be sure it summarizes all of it. Don't make this up in your head. This is stuff that I want from the text. So be sure your answers come from the text. All right, that's all for today.